Crystallography. We are now going to discuss some problems on the topic crystallography. First question. What will be the wavelength of X-rays which gives a diffraction angle 2 theta equal to 16.8 degree for a crystal if the interplanar distance in the crystal is 0.400 nanometer and only second order diffraction is observed? From the question, we can write n is equal to 2, d is equal to 0.400 nanometer, or it can be written as 0.4 into 10 raised to minus 9 meter. The diffraction angle 2 theta is equal to 16.8 degree. Thus, theta is equal to 8.4 degree. From the Bragg's equation, n lambda is equal to 2d sin theta. Here in the question, n, d and theta are given. Substituting the values of n, d and theta, we get the wavelength lambda as 0.0584 into 10 raised to minus 9 meter, or in angstrom unit it is 0.0584 angstrom. Second question. Calculate the distance between two lattice planes which give first order diffraction at an angle of 26.42 degree with molybdenum X-rays of wavelength 0.710 into 10 raised to minus 9 meter. From the question, we can write n is equal to 1, lambda is equal to 0.710 into 10 raised to minus 9 meter, and theta is equal to 26.42 degree. From the Bragg's equation, n lambda is equal to 2d sin theta. We have to find the value of d. Hence, rearranging and substituting the values of n, lambda and theta in the equation, we get the value d as 0.799 into 10 raised to minus 9 meter, or it can be written as 0.799 angstrom. Third question. For a simple cubic crystal, X-ray diffraction shows intense reflections for angles theta 1, theta 2, which are assigned to 101 and 111 planes respectively. Find the ratio sin theta 1 to sin theta 2. For the planes 101 and 111, we use the interplanar spacings D101 and D111. We know the equation of the interplanar spacings. Hence, we can find D101 and D111. D101 is obtained as A by root 2 and D111 is obtained as A by root 3. Now, using the Bragg's equation, n lambda is equal to 2d sin theta, we can find the value of sin theta 1 and sin theta 2. Sin theta 1 is equal to sin theta 101 is equal to n lambda by 2d101. Substituting the value of d101, we get sin theta 1 as n lambda root 2 by 2a. Similarly, finding the value of sin theta 2, that is sin theta 111, we get the value as n lambda root 3 by 2a. Therefore, the ratio sin theta 1 to sin theta 2 can be written as root 2 by 3. The value of root 2 by 3 is 0.82. Hence, the ratio sin theta 1 to sin theta 2 is equal to 0.82. Fourth question. X-rays of an unknown wavelength are diffracted by a gold sample. The 2 theta angle was 64.582 degree for the 2 to 0 planes. What is the wavelength of the X-rays used? The lattice constant of gold A is equal to 0.40788 nanometer. Assume first order diffraction n is equal to 1. We know that the interplanar spacing d is equal to a by root of h square plus k square plus l square. To find d2 to 0, we have to substitute a, h, k and l. Substituting the values, we get d2 to 0 is equal to 0.1442 nanometer. Now, using the Bragg's equation, n lambda is equal to 2d sin theta, we can find the value of wavelength. N is equal to 1, d is equal to 0.1442 nanometer, and theta, we have to find theta by dividing 64.582 degree by 2. Hence, we get theta as 32.291 degree. We get the value lambda is equal to 0.154 nanometer.